Welcome to the Rich Report, a podcast with news and information on the world of high-performance computing. Today, my guest is from Zettaset. We have Brian Christian. He is the founder and CTO of the company. So, Brian, welcome to the show today.
Hey, thanks for having me.
You bet, Brian. So, I'm curious about Zettaset and where you guys fit in the picture of big data and HPC. So, I've brought your slides up. Why don't we start with that?
Sure thing. So, kind of just real quick here, kind of going over what we do. First and foremost, we are an enterprise software company. With that said, what we've really done is focus solely in on big data and the architecture of big data. I know a lot of people have been looking at big data in the form of analytics, and that's great, but we kind of see that as the frosting on the cake. You gotta first, kind of bake in a big data solution in order to get those answers and get those results. And that's kind of where the complexity comes in of this whole big data kind of scenario that we've been hearing a lot about, the past couple of years. It's for a lot of people, big data means Hadoop. And I think they initially start out with a big data problem, thinking Hadoop's going to auto-magically solve that problem, only to then develop a Hadoop problem. So one of the things that we've done kind of out of the box is, kind of address people's Hadoop problem first and foremost, and kind of take the scary or the black magic voodoo away from this new type of technology. So essentially what we've done is created think of it as a wrapper. We call it an orchestrator. But what we've done is really kind of come in and kind of made the care and feeding of this Hadoop solution that you're looking at to manage your big data problems a lot more easier for the kind of the common person without having to become a big data kind of expert. Kind of taking this approach with the software. It kind of eliminates the needs on professional services. You don't have to have strange people on site 24/7, really kind of managing your stuff, and that really kind of lowers your TCO when it comes to looking to get into big data. The nice thing that we've done, I think, in our software is, there's a lot of confusion around the distributions. Do I use Apache? Do I use Cloudera? Do I use Hortonworks? When I'm looking at, do I use BigInsights when I'm looking at Hadoop? And I like to say that it all comes from the same well. It all comes from the Apache, Hadoop well. What guys like Cloudera and IBM and Hortonworks and MapR, to a degree, have done is kind of made it their own bottled water, right? So even though they've pulled up the same Apache code and they've kind of made their own bottled water and made their own distribution of it. And one of the things that we've done is be totally agnostic of those distributions. So, when you're installing our software, it basically says, what distribution are you using? We'll be more than happy to provide those components in. So I think that's the nice thing that really differentiates us from pretty much everybody else is giving you that freedom to change distributions midstream if you really wanted to. So if you look at where we fit kind of on the next slide here, we kind of talk about that core NoSQL at the very bottom. You have all the components, and if you look at the various distributions that are out there, you'll notice they have a lot of the same things. They've got Hadoop and Oozie and Hyve and HBase, and Pig and Zookeeper, and then you got some very specific ones like Scoop and Flume, and you've got Hortonworks, which is championing Ambari as a management platform, and there's different components, and there's actually many more components to the ecosystem as well, and this is exactly what the next kind of bar up there means. Kind of you've got the Cloudera guys, the Hortonworks guys, the IBM and MapR. They've taken all these different components and made it into their own distributions. And then you have this big gap of all the stuff that enterprises are expecting, and then you got that analytics up top. And if you see, when I start filling in here these boxes here under the services management gap, this is all the stuff that enterprises are really expecting, right? Enterprises say that's great. You've got all these open source technologies, which are fantastic. We get it, but there's a lot of things that are missing, to both the community, to inherent to all the distributions. Things like security. There is no security to Hadoop. That kind of shocks a lot of people. I think the community kind of brushed security on last minute with Kerberos, and now they're fully integrating it, but it's still, not a baked-in component. It's definitely brushed on at the end. But these are all the different things that, enterprises worry about. Compliances. Do I have to comply with HIPAA or GLBA or Sarbanes-Oxley's or a lot of the EU privacy laws, which are a lot more strict than some of ours. Things like access control, scalability. Is it easy to install and provision? How do I monitor it? How does it fail over? These are, all the different things that I think a lot of companies look at and are surprised to find out that, kind of the open source community is not addressed. And the way I like to describe it is, the community is kind of there to serve the needs of the community, not the needs of the enterprise. So the fact that the community hasn't addressed any of this just means that, it's just not a need for the community right now. It's not a priority item. But for a lot of these companies that have really turned on and jumped onto this, this kind of Hadoop bandwagon, that these are just business processes that need to be answered, right? So what we've done is kind of come in with Zettaset Orchestrator, and that's kind of what we've done. Is kind of filled in all those gaps with this layer, and it's kind of like an onion. We still actually have all those layers inside Hadoop and Uzi and all this stuff. But really, what we've done is bake this beautiful layer around it, and kind of provided all those things in one baked-in platform. And we kind of like to talk about it with saying it's management, administration, automation, and provisioning. And if you see, we added an S there. That's security. So that's kind of the big thing that we've added as well is really kind of addressing these needs. And that's really where we focus in on, kind of being the needs of the enterprise and being vocal for the enterprise. One of the things I want to point out is kind of one of the top quotes at the very top. It says 80% of Fortune 500 companies have a Hadoop cluster, less than 20% have it in production. I think this was a great Aberdeen quote. And it shows that, you got to ask yourself, well, if 80% of Fortune 500 companies have a Hadoop cluster, but less than 20% have it in production, why is that? Because anytime you get something over 50%, it's no longer an education issue. People know what Hadoop is. They got it, right? But if you ask, why is it not in production, the typical number one answer is they don't trust it. And if you ask them why they don't trust it, the number one answer again is, well, there's really no security. And that's one thing that I'd really like to kind of point out is the fact that, we talk about these ecosystems and we talk about, all these different distributions, but really none of these distributions have a unified security model, spread through them. So that's one of the things that we're remedying in what we call secure Hadoop, or as we jokingly refer to it as Shadoop, and really try to address those types of concerns. So I want to talk a little bit about, I think what we've done a little unique, I think, to the community. And if you look at our bundled big data management solution here, the thing behind this is I think you'll hear a lot of people talk about Hadoop on commodity hardware, and which is great. That was definitely what Hadoop was built and intended for. But I think you're kind of getting into these scenarios where you want, where people want to be able to process large data sets as fast as possible. And of course, if you look at any sort of way of doing that, you first kind of fall back to the hardware. What kind of hardware can we use? And one of the things that is notorious, of course, is Hadoop is mostly SATA disk based, and so you're limited by spindle speed first and foremost. And from there, it's one of the biggest performance hits behind behind Hadoop, is the fact that that is one of a limiting factor. So one of the things that we've done is we worked with a partner of ours, Hyve Solutions. They're a division of Synex. Synex is a great publicly traded company, $10 billion a year. And what we've done is actually derived an HPC big data Hadoop, if you will. And one of the things that we addressed was spindle speed. So we actually did some really neat things with Fusion IO, where we started using Fusion IO cards. So the moment, and this was really interesting, we wrote a great white paper about it, calling chasing the HPC bottleneck. The moment we addressed that spindle speed, the next bottleneck that we hit was processor memory bus. So we addressed that internally with some architectural issues, and then we actually hit the next bottleneck, which was the network. So we put solar flare NICs in it, 10 gig E, and it really we saw some massive performance increases. We had to do some fine tuning on Hadoop because Hadoop, keep in mind, was written with that commodity hardware in mind. So the moment you start removing those commodity hardware components and start putting in high performance components like SSDs and 10 gig E cards and some of the bigger processors and whatnot, Hadoop really kind of begins to perform a little odd. So we had to do some great fine tuning inside of that, which we learned a lot on. And then we decided to use Red Hat Enterprise Linux 6.2. Just because I think if you're going to spend, the kind of money for this type of a solution, you're going to want an enterprise OS. So as opposed to using a freeware OS, we actually decided to use Red Hat Enterprise 6.2 so that it was supported, and then wrapped our orchestrator completely around it. And some of the numbers that we have been seeing have been pretty astronomical in the ways of processing. We've actually taken a look at it, the fact that, on simply 5 machines, we could crunch a terabyte of data in less than 20 minutes. And that was just on a 5-node cluster, a very small one. If you extrapolate that out, in less than 40 machines, you can crunch a terabyte in 60 seconds. Now, to give you a comparison on that, the largest Hadoop cluster over at Yahoo crunched a terabyte of data in 60 seconds on 1,800 machines. So what we have done is reduce the footprint many, many times down to essentially 2 racks of machines versus, 180 racks of regular machines. So, having a solution like this has definitely caught a lot of people's attention. Have definitely have raised a lot of eyebrows on the fact that, hey, on 2 racks of machines, I can now crunch an entire data set, terabyte data set, in about 60 seconds. So that kind of brings us to what our recent announcement here has been with IBM and BigInsights. We really decided to kind of partner with IBM on Big D with their BigInsights for one reason, and that is it's a really cool distribution, and it gives us availability to a faster file system called GPFS. Now, natively, Hadoop uses a file system called HDFS, or Hadoop File System. IBM has been working with high-performance file systems like GPFS now for decades. And the performance enhancements, again, we see this as another way to make what we've already created with this HPC bundle even better, right? And the fact that they're IBM doesn't hurt either. They've definitely got some great technology, great analytics to put on top of this turnkey bundle, and can really start delivering value on information right away. So, if you take a look at this, what we have done is create a soup to nuts, turnkey solution. You can literally have it dropped off, plugged in, and turned on, and then, once you've got all your data inside of it and you're performing your MapReduce functions, you can decide exactly what kind of analytics you want to start trying to extrapolate from that data. But one of the things that we've really done is really made Hadoop for the enterprise, right? So it's no longer just a kind of an open source science project. We took an enterprise hardened Hadoop with BigInsights on enterprise hardware with an enterprise vendor, and we're now running enterprise applications on it. So this is something that I think a lot of people really have not been doing, that the enterprise has been asking for. Give me something that we can use in production that would actually fulfill our business needs. One of the things that I think that is also interesting is, since everyone has been kind of rallying around this mantra of commodity hardware, and what we've done is actually put some of this on HPC hardware, we can actually address hybrid environments where you can now mix both HPC and commodity machines together, and through a series of kind of cluster management and identification, we can put that data accordingly. Does it need to go on the HPC side? Does it need to go on the commodity hardware side? So we've kind of addressed a lot of these hybrid environments, and took Hadoop more into a heterogeneous environment as opposed to a homogeneous cluster, which is what everyone has kind of been using Hadoop for so far. And honestly, the big thing, as I said, no one ever got fired for buying IBM, right? So it gives us a great access to IBM's vast installation base.
Okay, well, thanks for that, Brian. A couple questions here. When you do this kind of turnkey solution with the open source components like Hadoop built in, do you still retain, the goodness and the benefits of open source when you wrap up something like this?
Absolutely, absolutely. I like to say that it's no different than being able to basically keep all those core components, kind of with the open source community. And again, keep in mind, kind of what we're doing here is putting a wrapper around this. So we're making it easier to use and really fostering and championing the adoption of this technology, which, we think is going to be the best big data technology that's going to be out there for a while. So essentially, we're not modifying any of those internal components. So anytime something internally changes in Hadoop and in the community, it gets reflected in our code. So we're not having to go back and recode stuff that's proprietary to us. What we've done is really take concepts, like high availability and how that's been done before in the past, and putting easier to use interfaces on it. So allow people to kind of consume this technology a little more easily than they would straight directly from the community.
And I wanted to ask you about the security component, Brian, because I've talked to a lot of vendors about big data and Hadoop solutions, and no one's ever brought up the word security before. Essentially, what brings that into the equation? Is it using the Red Hat Enterprise software as your base, or how do you bring that together?
Yeah, it's tricky. Because keep in mind, when you actually, we're talking about clustered computing now. So we're no longer talking about the database. We're talking about the cluster, and the cluster can be 200 plus machines or whatever. That's 200 potentially new targets for a hacker to break into. So, there's a lot of architectural approaches, but there's a lot of internal approaches that we can do to kind of mitigate that. Kind of keeping in mind that a lot of these individuals, or a lot of these companies, financial and government, military, critical infrastructure, medical, they've got a lot of compliances they got to do now as well. Even with the recent healthcare legislation, everything has to be electronic now. So, that's kind of forced healthcare into big data. Unfortunately, they've also got this restriction on them that says, well, if you're going to store data electronically, it has to be done in this way, right? So it's kind of one of these things where if they can't address, and this is going to be interesting, if they can't address the compliance that makes them store data electronically a specific way, but they have to store all data electronically, you kind of see where that catch-22 falls in, right? So one of the biggest things behind helping them to comply with that is basically doing this security. And we're not talking about, kind of reinventing the wheel here. This is stuff that, things like access control, encryption, that we can help to facilitate right away. But also, there was another vulnerability released just last night about Apache Hadoop, and people are really taking a really close look at it, and hackers are beginning to tear it apart. And I'll be honest with you, the conversation that we could have about the lack of security inside of Hadoop would be a lot longer than the actual conversation of what Hadoop has in terms of security. So by kind of an inherent value, Hadoop was never made to be secure. So it was never written with security in mind. And the fact that users can execute arbitrary code and masquerade as other users and things of that nature, there's a lot that's going to have to be done in order for enterprises to effectively use this inside of their environment. So, one of the things that we've kind of done is champion and picked up that flag and said, we'll help to address this right and foremost, and kind of take that down the road.
Well, terrific. And then we have a great listener base in the HPC community, and I was real curious about your implementation with the SolarFlare cards and the Fusion IO as well. SolarFlare has these ability to compute like right on the network card. Are you guys utilizing that capability at all?
So we are actually working very closely with those guys to find out exactly what the best way to do that. But we've got a very great working relationship with those guys, and those cards are pretty slick, and there's a lot that can be done, and we're looking to do a lot with those cards. So I think it was a great vendor to choose.
Yeah, and being able to process a terabyte in a minute. Is there any standard benchmark? Because that's kind of a generic thing, like a terabyte data set.
Sure thing, and there's a whole TeraSort, TeraGen, grid mix. There's a lot of different ways to look at that, and I think the one that people are looking at are literally those benchmarks, like the ones that were set by Yahoo. 1,800 machines, crunching a terabyte in 60 seconds, and we decided to take that same benchmark but kind of show the reduction in footprint. If you use more kind of high powered machines. So that was kind of our take. But yeah, there's a lot of different benchmarks out there and a lot of different ways to analyze that. But that was the benchmark set by Yahoo for Hadoop.
Well, great. And then I guess kind of a wrap up here, Brian, I wanted to ask you more about the IBM and the GPFS solution, because that's another thing I hadn't heard really discussed in the Hadoop world before, was their file system. So what advantages does that get? Is it just about parallel I/O, or what do you get?
Yeah, that's part of it. There's a lot of I don't want to say shortcomings or failings, but we know we kind of understand the limitations of HDFS, and in general, if you take a look at it, and this was something that MapR did. MapR went out and recreated their own file system to address some of the shortcomings in HDFS. We didn't feel the need to create another file system. There's plenty of distributed file systems out there. GPFS being one of them. It's been around since I think the late 90s. It's used on a lot of their supercomputing frameworks. It just made sense to us to not reinvent the wheel and kind of go with something like that. But yeah, it's a tested and tried solution. It has gotten some pretty good performance enhancements. A lot of behind a lot of the parallel stuff, but more importantly, they've really tuned it. It's because it's been around for over 15 years, so they've definitely kind of worked the kinks out of it.
Sure. Well, Brian Christian, I want to thank you once again for coming on the show today.
All right. Well, thank you again for having me.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.